Good morning and welcome to the third annual ELAP Conference. I'm Jen McLaren, Conference Co-Chair, and we are over the moon that you have joined us for this year's event. We are embracing the theme, ready to launch, like the bunch of sci-fi nerds we are. We hope that you'll have as much fun as we did planning it, laugh at our space jokes, and learn from and be encouraged by our stellar presenters. Hopefully, you've taken a few minutes to look over the agenda. For a quick review, today is our spacewalk day that will give us a space station eye view. Tomorrow is the moon shot, where we will hear from several of our LTAC members as they share some of the great things they are working on. And Thursday is the final countdown that will focus on T&I implementation. We have a host of laboratory stars to hear from over the next 3 mornings. Over 500 people have registered to join us this year, and more than half indicated that they did not attend our last conference. So it's time for a little bit of quick housekeeping. We are using Teams Live to accommodate the large number of attendees, and as an attendee, you can't unmute yourself or turn your camera on. Any questions you wish to pose to our presenters can be done through the Q&A chat box. We encourage you to put your name in the space provided. On your screen, you should see how to submit your questions via chat. During today's event, feel free to send in your questions throughout the morning at any time. We will pose questions to the presenters at the conclusion of their presentations. We also invite you to join in the conversation on our Slack channel. Last year, we were able to have great conversations, engage with our presenters, and add a little extra to the virtual conference experience. There is a link to join the Slack channel on the conference webpage, and we also have it available in a link in the chat box here. We are honored that you have chosen to be here as we celebrate that TNI -2 is ready to launch. We always have astronomical goals with this conference, but this time we really did reach for the stars. Our keynote speaker, Michael Roberts, is the Chief Scientific Officer of the International Space Station National Laboratory. managed by the Center for the Advancement of Science in Space Incorporated. Before joining CASIS in 2013, Michael worked as a principal investigator and research group lead in the NASA Advanced Life Support Program at the Kennedy Space Center. Please join us in welcoming Michael to ELAPCon.
Hi, good morning, everyone. Quick thumbs up if you can hear me fine. Sounds good. I wanted to take an opportunity to first thank the conference steering committee, and especially Christine, Jen, Leanne, and Caitlin for the kind invitation to join you today. It is indeed an honor to be able to join with you today. Each of you who's joining this call and participates in this conference is a first responder. I was thinking about this over the weekend. You guys are the guardians of the galaxy in the state of California and beyond for water quality measurement. And I want to acknowledge I am honored to join you today, and I appreciate your service to the state of California and to the nation in helping to maintain public health and keep us safe. If we could have the next slide, please. So I wanted to begin after that quick acknowledgement to let you know that, as you may have gathered from Jen's introduction, there's a lot of space references today, so feel free to treat this talk that I'm giving as a drinking game. Since it's early for you on the West Coast, please have a sip of coffee, tea, or water, whatever's next to your terminal as you're watching this. Every time you hear a space reference or you hear me use an acronym that I don't identify and you don't know what it is, take a swig and then send me a message on Slack or the Q&A to let me know to define what it is I just said. So I wanted to begin just with a quick introduction of what is the International Space Station and how in the world did a national laboratory get there. You can click one time, please. So this is a Q&A for you to do at home. The ISS is a very large human-made object assembled in space by international partners to operate in low Earth orbit, or LEO. So if you hear me talk about LEO, I'm not talking about lions, I'm talking about low Earth orbit for the rest of the talk. Click one more time. Or is it a human outpost in space where humans have lived and worked continuously for almost 23 years? Or, click one more time. Or it's a multi-user research and development laboratory and classroom in space that has included a national laboratory since 2005. The answer, of course, is that it's all of the above. No, please start.
The International Space Station is a state-of-the-art microgravity laboratory that is unlocking discoveries not possible on Earth and helping us push farther into deep space.
Every single day, we are answering big questions about Earth and about space, about where we came from and about where we're going. But the other thing that we're doing is we're learning more questions to ask.
Microgravity turns almost everything we know upside down. Liquids behave completely differently. Fire burns in new ways. Biological systems reveal surprises.
There's a few things that have made me gasp out loud up on board the space station. Watching heart cells actually beat has been a pretty big one.
We're studying ways to grow food in microgravity.
I got to tell you, these are pretty amazing.
We're learning how human bodies react to life in space and how to keep crew members safe and strong on long-duration exploration missions.
Deadlifts are awesome on Earth. They're also awesome in zero gravity.
We're testing technologies that will be critical to our return to the moon and Great Leap to Mars. Our research has contributed to medical and social benefits on our home planet, allowing us to find new ways to combat disease back on Earth and develop technologies to deliver clean water to remote communities in need. The spectacular vantage point of more than 200 miles above our planet supports our monitoring of Earth's climate, natural disasters, and plant life.
I can't begin to describe some of the sights that you get to see. It's just an incredible view of our planet that we have from here.
The growing new space economy, so vital to our continued progress in space, is flourishing in low Earth orbit. We're inspiring future generations from a platform that is one of the largest international collaborations of our time. We're doing science at 17,500 miles per hour. Come along for the ride.
Click one time. So the International Space Station is your laboratory off the Earth for the Earth. I'm very pleased to be with you today. I'm fortunate to be the ISS National Laboratory Chief Scientist. My role at the ISS National Laboratory is to work with teams of scientists, teams of engineers, teams of innovators and entrepreneurs to understand the possibility of taking their R&D needs or their education outreach needs to space. For the first time in the history of humanity, we have the opportunity to launch multiple size payloads into low Earth orbit and beyond, and to actually have those payloads executed and observations from space made not only by astronaut crew from the different space agencies around the world, but actually everyday citizens. So we're seeing a major transition in low Earth orbit now that was in large part started by the launch and assembly of the International Space Station in orbit that is enabling the democratization of space. So in its nearly 23 years of operation in space and continuous crewed operations, the International Space Station has led to advancements not only to support NASA's research goals and continuing our exploration of space, both by remote vehicles and by human-tended vehicles, but also supporting the research and technology development needs of the United States and other nations around the world. These new discoveries have been realized in human research by observing crew health and performance in the space environment, as well as animal models in some cases. Expansions of new technologies in biotechnology that translate into improvements in medical devices and medical therapeutics, both inorganic and biologically based for use here on Earth, as well as fundamental discovery science. We work in collaboration with U.S. government agencies, including the National Science Foundation, the National Institutes of Health, various programs within the Department of Defense, and other programs within Health and Human Services to support fundamental science discovery as well as translational medical research in the space environment. So with the National Science Foundation, for example, we have an annual solicitation that focuses on combustion, fluids, and materials science in the space environment. We also offer opportunities in partnership with NASA for Earth and space observation, both crew-tended and remote. And there are multiple opportunities for technology demonstrations in space. In some cases, those technology demonstrations are taking advantage of the harsh environment outside of the International Space Station so that you have an opportunity to test materials and the performance of devices that are actually operating in space and beyond through the use of the International Space Station as a launch platform. So the International Space Station also can currently serve as a launch platform for small satellites that operate in low Earth orbit and beyond. More recently, we've expanded the portfolio in partnership with NASA to begin looking at in-space production applications. So these are technology demonstrations that are more mature and are seeking access to space in order to manufacture or process a material or product that can have utility here on Earth and offer better performance characteristics. And I'll give some examples of that later in the talk. And then through all of this, the International Space Station has continued with a primary theme of NASA and our nation as a whole to leverage space and the opportunities we have there for educational outreach and workforce development. Next chart, please. click once more. And once more. So the ISS National Laboratory is in part a realistic destination that is part of the International Space Station. My role as chief scientist in the organization I work with, which is Center for the Advancement of Science in Space, the acronym for that is CASIS. We tend to say CASIS, but depending on which part of the US I'm in or which country I'm in, it's CASIS, it's CASIS, it's different pronunciations. None of them are wrong. All of them are right. Doesn't matter how you say it because it's an acronym at the end of the day. But we serve the will of the nation in managing what is currently the premier space laboratory in low Earth orbit. It has been joined recently by the Chinese space station Tiangong, which is also beginning to establish real-world credentials in leading scientific discovery in space. Our vision as managers of the International Space Station National Laboratory in partnership with NASA is to be the leading source of innovation in space, enabling life-changing benefits for humanity. So the portfolio of research, technology, development, education that we have on the ISS National Laboratory does not replace NASA's portfolio. It operates in parallel to it. NASA and other spacefaring agencies around the world continue to use the International Space Station as well as other platforms to further the goals of human exploration of space. What we have done with the creation of the International Space Station National Lab in 2005 is to add to that the ability for other US government agencies and industries and state institutions, not-for-profit institutions, and private individuals to have access to the space environment. We can click. So this is what the International Space Station looked at assembly complete, and over in the right you see the symbol for all of the international partners who participated in the design, assembly, and integration, and now 23 years of operation of the International Space Station. So the International Space Station is not only an engineering marvel operating in space, it has been considered for a Nobel Peace Prize in past years due to the ability of each of these nations to get together and work in unison to build a unified structure for the support of research and technology development to advance humanity. Next chart, please. The International Space Station itself is an extremely complex device, and as I mentioned, there are international partners who have provided different parts and pieces of it. So although there have been struggles with geopolitical changes over the years and changes in the relationships of those nations, the ideal standard that was set by the creation of the International Space Station is stay true. So that as we currently speak, the International Space Station currently has on board a resident crew of 7, comprised of an astronaut from Saudi Arabia, 3 from the United States, and 3 from Roscosmos. We are, as we speak today, have set a record for the number of people living off Earth in space. There are currently, as we speak today, 17 people who are in low Earth orbit. In addition to those 7 that I mentioned on the International Space Station, the Axiom 2 private astronaut mission. This is the second of the private astronaut missions that have been sponsored by Axiom, where a crew of non-NASA astronauts were able to launch to the International Space Station to conduct research and science, investigation, and educational outreach. They're returning today. They undocked from station just a little over an hour ago, and they'll be returning off the coast of Florida a little bit after 11 p.m. Eastern Daylight Time this evening. So those are another 4 individuals who are currently off the planet. There are 3 Chinese taikonauts who are currently on board the Chinese space station, and a crew of 3 to replace them just launched yesterday from China. So they're currently catching up to Tiangong and will dock to Tiangong later today or early tomorrow, and then there'll be a crew exchange, and those 3 will come back. So for the first time in the history of humanity, we have 17 individuals who are living off the Earth today. Next chart. So the International Space Station, as you may have realized from the introduction in that first video, is orbiting the Earth at 17,500 miles per hour. This is orbital velocity. So that offers an opportunity for the creation of a free fall environment. So we talk about, and I will talk a lot about microgravity in this environment. Understand that from the viewpoint of a physicist, gravity is not that diminished at the altitude at which the International Space Station operates. But due to its forward velocity, you've canceled out the pull of Earth's gravity, and you've created a free fall environment, which leads not only to a scientific discovery, but it provides opportunities for the crew members to get a lot of great playtime in with M&Ms and water and other strange things that happen when you're in that type of free fall environment. Next chart. The International Space Station also offers these unparalleled views. So for those of you who are fans of the real estate market, it's true what they say about location, location, location. So the operating environment of the International Space Station at about 200 miles above us offers unparalleled views of the Earth. The orbital inclination of the International Space Station passes over 90% of the humanity that lives on the surface of the Earth. So that offers opportunities for remote Earth observation, and more importantly, for testing technologies that can improve our ability to understand climate change and other environmentally important variables from the space environment. So I mentioned that the International Space Station is a very active and busy place for technology demonstration. The International Space Station has been used extensively over its 23 years, nearly 23 years of operation, for testing out new sensors and the integration of new sensors. Most recently, looking at hyperspectral and polyspectral imaging from space to be combined with small satellites and then drones here on Earth. Next chart, please. Inside the International Space Station is what we call the shirt sleeve environment. That's where you see videos of the crew members interacting with a multitude of platforms on board the International Space Station to support education outreach as well as fundamental scientific discovery. So unlike what you may have seen from science fiction movies where the interior of the spacecraft is pretty pristine and styled, the inside of the International Space Station is full of cables, full of cameras, and quite busy with crew members tending to different experiments. And a typical 6-month rotation on board the International Space Station, each crew member will support somewhere between 300 and 400 experiments that are not their own. So these are science and technology demonstrations that are built on Earth and led by investigators who aren't able to support them while they're up in orbit. So the crew has to be the hands, ears, and heart of the scientists and engineers back on the ground. Next chart. So I mentioned quickly about microgravity environments. So one of the major benefits of operating in this environment is the ability to explore the fundamental physics of devices, of materials in the absence of gravity here on Earth. So once you escape the gravity well in which we live, you're able to understand the impacts of other processes that are often masked at a molecular, micro, or nano level. So in microgravity, you have a near complete absence of buoyancy-driven convection. So where you're dealing with materials or fluids that have different densities or different molecular weights, you're able to keep those in suspension for far longer because gravity is not pulling down on the heavier elements or the heavier, more dense materials inside the liquid. So This offers opportunities for investigations in material science and combustion science, which have been exploited not only by National Science Foundation and other funding agencies, but also by industry. So we have worked with Goodyear. We've worked with a variety of materials manufacturing companies to exploit that environment so that they can better understand some of the fundamental physics that underlie their ability to manufacture products with superior quality. Next chart. In addition to that continuous exposure to a microgravity environment, outside of the International Space Station and low Earth orbit, you have the extreme environmental conditions of space. So you have over 400 degree Fahrenheit temperature shifts from when you're in sun and when you're not. The International Space Station completes an orbit about every 90 minutes. So over the course of a day, they'll see about 17 sunrises and sunsets. And any of the materials in the International Space Station itself experience these dramatic shifts in temperature because they are in fact operating in a vacuum. So they are directly heated when in the sun and quickly cooled to the blackness of space when they're on the opposite side of the Earth from the sun. This affords opportunities for testing materials and component devices. In many cases, these materials are designed for operation in a space environment. So these materials historically have primarily been used for use in other spacecraft as components or parts of other satellites. More recently, we've seen just simply the use of exposure to that space environment as an accelerated test bed so that you can take materials that may not be intended for the harsh operating environment of space, but can derive some benefit from accelerated exposure testing in that environment. You also have the opportunity in that environment to test communication systems as well as sensory devices for operation here on Earth. So we've seen a multitude of investigators from Fortune 500 companies as well as small business startups that seek access to the conditions outside of the International Space Station. Next chart. And last but not certainly least is the ability of the International Space Station to operate as a unique vantage point. So what you're seeing here is the look outside of the cupola on board the International Space Station. So the crew has real science to do here and that they do conduct Earth observations and imagery from inside the cupola. But even more importantly, from the human perspective, they have the opportunity to chill and take a break inside the cupola and enjoy the view outside their window, which is unlike any other view in the world. Next chart. All of this on the International Space Station and the role of the ISS National Lab keeps in mind this one shining pale blue marble out in space, our Earth. So all that we do at the International Space Station National Lab in partnership with NASA is in service to our planet and furthering the enterprise of science for the benefit of humans here on Earth. So one of the things that I like to recall in talking about the International Space Station and our focus, when we were initiating the Apollo program as a nation back in the 1960s, the focus of that was to put a man on the surface of the moon before the end of the decade. And along that journey of achieving that national, if not global goal, we found that images of our pale blue marble of a planet hanging out in Earth brought to home just how precious, unique, and special the Earth was from that perspective. And this indirectly or directly, led in part to the founding of Earth Day and has sustained us ever since. And that whenever we are off of Earth and looking back at Earth, we understand just how precious our planet is. So although the goal of the Apollo program was to put humans on the surface of the moon, one could argue that we made an even greater achievement in understanding the fragility of our planet by being able to see it from space in true color for the first time. We've also experienced a similar, I guess, kind of mind reset with the International Space Station. The International Space Station was designed in the 80s and 90s to serve the goal of NASA and its international partners in establishing a research platform for continuous human presence in space. So it was focused on, providing access to space so that we could continue to learn how to live and work there near Earth, so that we could eventually venture farther into space, the moon, Mars, and beyond. But while doing that, we've learned a considerable amount about our own humanity, the fragility of humans living and working in that environment. And those discoveries about the physiology of humans in the extreme environments of microgravity, with exposure to microgravity in the radiation environment for several months, have led to fundamental medical discoveries and the translation of medical science into new therapeutics and new devices here on Earth. So although it wasn't one of the designing principles of the International Space Station, one could argue that the ability to utilize the International Space Station as a research platform has had even more benefit to those of us here on Earth than simply demonstrating that humans can live and survive in space in low Earth orbit and maintain the operation of a large research facility in that environment. Next chart. So where do we go from here? So we have demonstrated through the auspices of NASA and the international partners that it is now possible to live and work in low Earth orbit. So in the words of several observers of science, to go back to low Earth orbit is to go where many of us have gone before. So it's not a final frontier anymore. With the advent of reusable rockets led by SpaceX and Blue Origin, with new technologies looking at more efficient chemical propellants, as well as non-chemical propulsion systems that can be used in space, we are no longer as tethered to the Earth as we once were. So we now live in an age where it's possible for private citizens to travel to space, or at least into suborbital environments. The cost of that is still pretty high, tens of thousands of dollars, if not tens of millions of dollars for low Earth orbit. But the cost continues to come down as the technology matures and improves. So we, I think, are on the cusp of truly becoming a spacefaring world where space is no longer the provenance of large primary countries that have long-standing space programs. We are now seeing the true democratization not only of low Earth orbit, but people are reaching for the moon and Mars and beyond. Next chart. So one of the things that we're in charge of in partnership with NASA in operating the International Space Station was to continue the excellent record of research that the International Space Station had supported, even though it was being built out. Now, if you could imagine building your home and then having to operate a kitchen outside of your home to serve to the community, that's what was going on from 2000 to 2010 on the International Space Station, the decade of assembly. That was followed by the decade of utilization, and click one more time. Where we are now, the decade of results. So the International Space Station is slated to operate in low Earth orbit through about the end of calendar year 2030, when, although it will still be able to be supported from an engineering viewpoint and can be operated safely, it's very likely to be prohibitively expensive to do so, as it ages operating in that harsh environment. The safety margins become much thinner, and you have to spend more time on maintenance and operations of the vehicle. So NASA has published a plan to transition to commercial LEO destinations, or CLDs. And with that, the ISS National Lab, with the return of the International Space Station to Earth, it's going to be scheduled to splash down in Point Nemo sometime after 2030. There will be new commercial platforms operating in space, and the commercial marketplace has already been at work with over $500 million of NASA funding, and even more importantly, private capital to support not only the design, but the construction of these new space stations. So from left to right, on the right of this view graph, you see the Axiom space station. Next to it, you see the orbital reef, which is supported by Blue Origin and Sierra Space, among others. Next to it, you see Starlab, which is a single flyer, free flyer platform that is being developed by Voyager Space and NanoRacks. And then over to the right of that, you'll see a module that is going to reuse some habitat modules that are being designed for use on the moon or orbiting the moon by Northrop Grumman. So each of these commercial companies and their partners are currently designing and beginning to build these space stations of the future. So sometime around 2027, these one or more of these will be operating in low Earth orbit and begin to take over some of the responsibilities of the International Space Station in supporting crewed operations, research and technology development on behalf of the nation, supporting NASA and other U.S. government agencies, and serve as tourist destinations. So each of these modules can also support tourists or investigators funded by commercial interests to utilize their unique facilities. So we are currently in the transition zone in continuing to utilize the International Space Station for the next 7 years or so, and also beginning to work with our commercial LEO destination partners to establish a seamless transition from the capabilities on board the International Space Station to what they have to offer. Along with that, since the International Space Station will no longer be operating in 2030, NASA and the White House have published documents indicating the creation of a low Earth orbit national lab. So the ISS National Lab will in the future transition to a LEO National Lab, which could be distributed across multiple commercial platforms. So it will no longer be a single destination. Next chart. So while we continue to work here at the International Space Station National Lab with our partners at NASA, NASA continues to utilize the International Space Station to mitigate risk in moving NASA's exploration goals beyond low Earth orbit and beginning to focus on the moon and Mars and beyond. So while the International Space Station continues to operate in low Earth orbit and these new commercial platforms are being developed, NASA has identified several research facilities and technology gaps that currently would make it difficult for us to sustain operations for human crews on the surface of the moon, orbiting the moon, or in the not too distant future, transitioning to a voyage to Mars. So each of these areas of risk mitigation from the viewpoint of NASA are designed to ensure human safety as we move farther and farther from Earth. As we move humans farther and farther from Earth, the risks increase dramatically because of increased exposure to radiation environments, which are far more harsh than what the International Space Station experiences inside the Van Allen belt in low Earth orbit. You also have, for some of these missions, especially those to Mars, crews are going to have to live and work in space for over 2 years at a time. We've currently, only had humans on the International Space Station for a little over a year in one continuous day. So we're looking to establish new standards for crew safety and performance in those environments. So NASA is continuing to use the International Space Station to help address those risks. Importantly, though, they are joined in these efforts now by increased participation from the commercial sector. So there are private companies that are not only developing these new platforms to operate in space, but they're also developing new technologies to help address their market targets, which include tourism in space. So they're looking at new innovations in training for individuals who may not be as tuned and trained for operating in the space environment as astronauts are. So everyday citizens will be able to go to space and experience the microgravity environment there. Next chart. So what is our vision as a nation? So NASA has expressed it this way. The Artemis program is designed to send the first women and the first persons of color to the lunar surface and safely return them to Earth before the end of this decade, well before the end of this decade. By the end of this decade, NASA is on track to to build and sustain a facility on the moon by the end of the decade. They are joined in this goal by China, who's also expressed a goal to have Chinese taikonauts visiting the moon by 2025, by end of 2025, and to establish a moon base sometime around 2030 or even before. And then NASA and our nation, in partnership with international partners from around the world, will seek to leverage those lunar missions to prepare for a human mission to Mars, possibly in the 2030s. That goal is a little bit more tenuous in that there are some hazards which I'm not completely convinced we're going to be able to mitigate sufficiently, but given sufficient national will and continued progress on building those new systems to allay risk, we should be able to start thinking about Mars missions in the 2030s. Next chart, I think, is another video. You may need to start it. Click one more time.
I'm Christina Cook. I'm a mission specialist.
I'm Jeremy Hansen. I'm a mission specialist.
I'm Victor Glover. I'm the pilot.
I'm Reed Wiseman. I'm the commander for the Artemis II mission to the moon.
To the moon.
To the moon.
To the moon.
When I was young, I had a poster of the Earthrise picture, the famous picture that was taken on Apollo 8. And the fact that it was a human behind the lens that made that picture so profound and changed how we all thought of our own home was so amazing to me. The moon is not just a symbol of thinking about our place in the universe. It's not just a symbol of exploration. It's actually a beacon for science. It's a beacon for understanding where we came from.
You know, pushing ourselves to explore is just core to who we are. That's a part of being a human. That's our nature. We go out there and we explore to learn about where we are, why we are, understanding the big questions about our place in the universe. The exploration we're doing is the first few steps on the path of getting humans to Mars.
The Artemis campaign of missions have set such an ambitious goal for humanity that it's inspiring contributions from around the globe. Not just one nation is inspired and moved by this, but nations from around the globe are coming together. When I look at the Artemis II crew with Victor, Christina, and Jeremy, they want to go do this mission. They are keenly driven. They are humble to a fault. It is so cool to be around them. Artemis II is a huge mission, but I hope we will look back and realize that this was one tiny step in humans on Mars and a sustained presence on our moon. Start. Artemis II will be NASA's first crewed flight test of the Space Launch System rocket
and Orion spacecraft around the moon.
To verify today's capabilities for humans to explore deep space
and pave the way for NASA's long-term human and scientific presence on the lunar surface.
We are ready.
We are going
to the moon
for all humanity.
We are Artemis.
So this is the Artemis 2 mission, which is scheduled for launch in late 2024. It may go into early 2025. But as you heard the crew state in their video, this is a extremely ambitious and difficult journey in that the Artemis vehicle has been to space once. This will be an opportunity to test out a variety of new systems that have their legacy in the Apollo program, but are vastly different given the technological advances that have been made over the past year. So the opportunity to demonstrate these with crew doing a translunar insertion, orbiting the moon, and then returning back to Earth safely will set the groundwork that's going to be necessary to move larger payloads to the surface of the moon for research and technology development, as well as they mentioned, setting the stage for our eventual voyage to Mars. Next chart. So in thinking about the first human Mars mission, let's say in 2030, NASA has proposed a baseline crew set of 4. It could be larger than that. 4 is considered the absolute minimum in order to have that mission. You not only have to be concerned about the transit mission of getting to Mars, but if you're intending to land on the surface of Mars, as a famous botanist did in The Martian, you need to understand the technologies that are required for safely getting down. Well, first, getting into safe orbit around Mars, having a vehicle descend to the surface of Mars, and then return back to the vehicle to get back to Earth. So all told, that is going to require multiple technology advancements, not only related to propulsion systems, but to environmental crew life support systems, which I'll talk about a little bit here. Next chart. So I mentioned environmental control and life support systems. In the business, they call those ECLS. So these are all of the necessary life support and environmental monitoring and environmental safety requirements in order to have humans in the loop, whether that's on a vehicle in transit or on a surface habitat. These must function hand in glove with crew health and performance systems, or CHIPS. So in order to sustain humans in low Earth orbit on the International Space Station or in the Dragon capsule, as the private astronaut mission AX-2 is doing today, you have to have not only environmental control and life support, but you also have to have systems which are dedicated to maintaining crew health and performance while they're in the harsh environment of space. Next chart. So moving away from low Earth orbit into deeper space presents some challenges in that you have to maintain life support and environmental monitoring with logistical lines or resupply that is far longer and far more difficult to do. So in the case of a mission to Mars, it's an impossibility to launch from Earth and have systems available to back up your critical environmental control and life support or crew health and performance system. So if you need it, you better take it with you. So NASA is working in partnership with industry here in the United States, as well as international partners around the world, to improve the current systems that we utilize in space for environmental control and life support and crew health and performance. Next chart. I'm not going to walk through this entire chart. What I wanted to highlight was mostly in the middle on the left. Today on the International Space Station in blue, you see that we have about 90% water recovery. It's bouncing around 92, 93% in a given increment. We have about 47% oxygen recovery from carbon dioxide, but that comes at a relatively heavy cost. We have to frequently fly spares and orbital replacement units, and the crew has to spend a considerable amount of time maintaining the systems that recover water from urine and humidity condensate on board the International Space Station. So as we start to think about moving to the moon for lunar habitation or lunar orbit, and then onto Mars, we need to increase the fidelity of those recovery systems and make them more failure resistant and able to operate without extensive maintenance or resupply or orbital replacement units for longer periods of time. So in order to sustain a crew of 4 on the Mars baseline mission, we need to up the water recovery to about 98%. There are ways to do that. We need to increase several-fold the oxygen recovery from CO2. And in addition to that, since you may be operating in a surface environment where there are long periods of equipment setting quiescent without humans in the loop, those systems need to be robust enough to be able to be started remotely or operate in the absence of human tending for long periods of time. And they must also work in some environments with exposure to planetary dust, which on the surface of the moon is quite hazardous. Coupled with all of these improvements in environmental control and life support systems are advances in understanding what is actually needed to maintain crew health and performance, as well as maintaining overall environmental safety of the system. So open fire is never a good thing inside a vehicle, in the air or in space especially. And you also need to be able to keep track of everything, because if you are living off of Earth, as I mentioned, you have to take everything with you. So as you can imagine, those of you who go camping regularly, often you either forget to bring something or you bring it, you know you brought it, but you just can't find it. It's buried somewhere in the tent poles or somewhere else. And it's not as easy to go back and get that when you're on the surface of the moon or Mars as it is here. Next chart. Just quickly, I'm going to go through some charts just to show you the complexity of the endeavor here. So NASA and its partners are working on multiple systems for getting us safely to the moon and Mars, and for descent and landing and habitation on those systems, beginning with the moon. Next chart. Landing humans on the moon. We did it back in the late 60s, but this time we're there to stay. So the crew interaction with the South Pole on the moon is going to be far longer and require far more integration for support of human operations in that environment. And all of this is not only going to be beneficial to us here on Earth as we learn to explore the moon and learn a lot more about the moon than we were able to learn in the 60s and the decade since, but we're also setting the stage for voyages to Mars and beyond. Next chart. So once we establish the ability to operate in the lunar orbital environment, and to establish the ability to descend and land on that environment, NASA, like China has declared, is focused on establishing an actual camp to operate near the South Pole. The reason they're going to the poles is they found that there's readily abundant water there, water ice that's available, that offers several advantages for the resupply. Next chart. So things to keep in mind if your gaze looks up at in the night sky, you can pick Mars out when it's visible. Is trying to get there is more difficult than it is even getting to low Earth orbit, but they're all bound by the tyranny of the rocket equation, which essentially means that in order to defy gravity, the scaling of the rocket fuel goes up faster than the mass of the rocket, right? So you can get more payload into orbit, but it's also going to mean significantly more fuel is required to do that, and that takes away from the available payload that you have. So an open loop environmental control and life support system for a crew of 4 on a round trip to Mars, which is projected to take about 900 days. That means that in order for our planets to align and you be able to get to Mars on the shortest possible trajectory, you'll have to stay in the orbit of Mars or on the surface of Mars for about 6 to 9 months, and then then you will have your first opportunity to return to Earth. So it works out to about 900 days. You're going to require over nearly 26,000 kilograms of just water, oxygen, and food. That's not even counting the containers or the devices necessary to maintain the water to potable standards or make sure that you're not losing the oxygen. So you're looking at over 40 tons of food, water, and oxygen to maintain a crew of 4. So it's a heavy lift in order to get there. Next chart. This is what it currently looks like on station, and I am, as a trained biologist, I'm not capable of walking you through each of these systems, but I can point you to the literature if you're really interested. These are the systems that we use on board the International Space Station to purify air and water. So currently on the water side, they're at about 92 to 93% recovery from humidity, condensate, and urine. They need to get that up to about 98%. So they're going after squeezing the last little bit of water out of the brine that comes after the pre-treatment of the water there. And they need to increase from under 50% oxygen recovery to greater than 75% oxygen recovery. So we have baseline systems which have been shown to be operable in low Earth orbit. And what they're doing now is looking at some different ways to recover the oxygen and get rid of the from carbon dioxide, which with humans in the loop is going to be one of the primary supplies of the oxygen system. At the same time, they're also working, NASA, in collaboration with industry international partners, are working on improving the operability of standards and devices for inline water monitoring and TOC in the treated water that is recovered. Next chart. So I'm going to wind up here. I wanted to get to the last video and what we have. So these, I'll certainly provide these charts for those of you that are interested in diving a little bit more. And as I mentioned, follow up if you have questions, and I can point you to other presentations and the original literature that talk about these. Next chart. Same on the environmental monitoring side. This is where we currently are and where we need to get in order to sustain a crew visit to Mars. Next chart. So the International Space Station is available. That's Christina Cook, who you met as one of the Artemis astronauts. She's already served on board the International Space Station. Next chart. And I'm just going to go through these to provide insight into our portfolio. We are supporting tissue on chips research in the space environment that's leading to new discoveries for stem cell biological printing, bioprinting in the space environment. Next chart. Pharmaceutical discovery and design led in part by investments and grants funded by the National Institutes of Health, as well as directly by industry. Merck Pharmaceutical, GlaxoSmithKline have all funded that research. Tissue engineering and biomanufacturing. We are flying tissue chips to space to understand how microgravity offers an accelerated model of certain diseases here on Earth. Next chart. Advanced materials and manufacturing. Again, in the absence of gravity, we're able to form materials that you cannot in any way synthesize here on Earth using present technology. Next chart. And technology development demonstration. So once you understand the materials and or the biological components, you can take them to the space environment and see how they work in an actual system. Next chart. And fundamental science. We continue to work with the National Science Foundation and other agencies in the United States government that fund fundamental research. Next chart. STEM outreach. At the heart of everything we do, there is a young scientist, a young engineer, a young water quality technician urging to be set free and understand how they can contribute to the future. Next chart. Workforce development. We are starving for educated individuals who can do communications, who can do engineering, who can do science in the space environment, and can do contracts and business. And Station is there to serve. Next chart. Next chart. So I'll end there. There's a couple of charts at the end here, which I'll provide as a PDF if you're able to get those. that will enable you to ask more questions. I thank you for your time today. It truly was a pleasure to be able to join you. And thank you so much for listening.
Thank you so much, Michael. We do have a couple questions and we do have a couple, like 3 minutes, so we'll try and knock them out pretty fast. First of all, what did you say are some similarities between a lab in low Earth orbit and labs here on Earth?
Well, quality standards are extremely important. So we have certain tools that we have to use on orbit and back here on Earth to understand the quality of the environment in which the crew lives. Obviously, of paramount importance of anything that we do on the International Space Station is maintaining crew health. So a lot of the advances that have taken place here on Earth about reducing the volume of reagents or the sample volume you have to test in order to get an idea about water quality or air quality, those are extremely important in space environments. So some of those technologies that have been developed through funding by NASA have already translated back here to Earth on new kits and new systems. And of course, anytime you're doing those in-field analyses, you need to be able to understand that you're measuring the right analyte and there's no competing analytes in there. So all of that ties back together again with technology development here on Earth for water and air monitoring that are extremely important as we continue to pollute our environments.
And then I think we'll have time for one more. It says, how will the incorporation of robotics and AI impact the vision of the International Space Station?
Extremely important. So there are certainly things that robotics can do for us that humans in the loop can't do, working in harsh environments. And the robotics and artificial intelligence and machine learning, I will add to that too, AI, ML, are extremely important in increasing our ability for throughput. So just as you are, I think, are sometimes challenged by the number of samples you have to process in a given day, so you look for ways to automate processes, we have those same constraints in the space environment. So combining robotics with artificial intelligence and machine learning to cut through the noise and get to the data are drivers in that system. So NASA and the partners continue to look for new ways to accelerate those technologies for use not only in space, but here on Earth.
Perfect. Well, I think we're out of time. I want to thank you so much, Michael, for joining us and for that inspirational presentation. And I want to let our audience know that Michael has graciously joined us on Slack for today. So if you didn't get your question answered, please feel to pop over there and we will try and populate some of the questions that are already in the chat box over there for you, but also give you a chance to ask some other questions while he's over there just for today. And with that, we're going to bring things back down to earth. And what a better way to land than with a presentation from the State Water Board's Quality Assurance Officer, Andrew Hamilton. His role is to maintain the Water Board's quality management system and support the implementation of quality assurance policies and procedures to ensure the production of and acquisition of quality data. Andrew has over 12 years of experience working in the environmental laboratory industry, including as a laboratory director and technical manager of an ELAP accredited commercial lab. There are few people that I have met that are as genuinely excited about quality as Andrew. Please welcome him to the ELAP Con stage.
Oh, awesome. Thank you so much, Jennifer. I really appreciate the warm welcome. And I want to say good morning to everybody today. Thank you, ELAP, for asking me to present today. And also thank you to Dr. Roberts for an illuminating talk. I don't know about everyone that's listening, but my focus was definitely on space exploration into Mars and the moon and possible presence of humans in those environments. Really got me thinking about all my sci-fi nerdy stuff that I like to think about when I'm not thinking about water quality and quality assurance. But as Jennifer said, I'm the Quality Assurance Officer for the State Water Board, and I'm uniquely positioned to kind of give a talk today because I have a really expansive working relationship with the environmental laboratory community because of my involvement with managing the DMR QA program. I'm the ATP coordinator for the state. I uphold the quality standards for our enterprise database systems like CDIN, CWIX, and work with the GeoTracker system as well. And also I help implement the QA within our statewide chemistry contract portfolio. So I have a large exposure to the environmental laboratory community, and that's what brings me here today. Really, I want to celebrate and really talk about and advocate for our environmental laboratory community. Actually, you go back. I want to just talk about this. If you don't mind, talk about this title. I don't want to. Let me just say, I want to embrace the space theme of this conference today, and I thought no better way than to bring in some of my Star Wars references. So you might see some spread throughout. I have to be careful because it's all copyrighted, and I probably don't want to get in trouble with Disney, but I did want to mention that this title really comes from, it's really in honor of the accredited environmental laboratory community and the efforts that you're going through right now to implement the TNI2 laboratory standard in your laboratories, and also in recognition of all the important work that the environmental laboratories do and the important role that they have in the regulatory activities of the water boards. So that's really what this title comes from. And we can move on to the next slide, please. Thanks. So like I said, I'm here to really celebrate the environmental laboratory community and what you bring to, and the data that you provide, and how that brings value to what we do at the water boards and other regulatory agencies at the state. The contribution that you have to our regulatory activities is immeasurable. Really, the data that you provide is what is used to inform our management decisions, and it's also used to uphold our data quality standards at the water boards and, like I said, other regulatory agencies. I will also be talking about some of our collaborations and partnerships with the laboratory communities, specifically advancing our monitoring efforts by integrating new methodologies and analytical approaches to our monitoring efforts in a way to expand our analytical capabilities and really tackle the challenges that we face here in California. Next slide. Great. I want to just set the stage here with talking about the water board's responsibilities and our mission. Hopefully, this weekend you have the opportunity to actually visit one of these wonderful sites here, but it's the responsibility of the state and regional water boards to protect the water quality of nearly 1.6 million acres of lakes, 1.3 million acres of bays and estuaries, 2011 miles of rivers and streams, which has definitely expanded since our wet season that we just had, and approximately 1,100 miles of exquisite California coastline. That's the charge that we have at the water boards. And really, everything that we do is supported by the data that the laboratories provide. Outside of regulating the water quality of these water bodies, we also regulate over 8,000 community and non-community public water systems, and we implement water quality, water rights, and drinking water programs, permit programs. And like I said, they utilize all the laboratory data to support the critical decisions, and it's really the foundation of the regulatory activities that we can implement here at the water boards. Next slide. Here's just a kind of a snapshot of some of the water regulatory programs that we implement here at the water boards. And I'm sure if you look at all those, the laboratories that are listening in and the people that are probably have provided data for one or not many of these programs. And this is just a snapshot. There's many more state and regional monitoring programs that occur that utilize the important data that you provide. Next slide. But it's not isolated to just the water boards. The ELAP accredited laboratory is responsible for helping support the regulatory activities of many of our partner regulatory agencies like CDFA, DTSC, et cetera. And data is used from the laboratories to support such activities as screening pesticide residues in foods, asbestos, hazardous and waste testing and cleanup, safer consumer product testing, and lead testing for schools and daycare facilities, to just name a few. So the accredited laboratories community is definitely an integral part of what we do in California as far as a regulatory framework. Next slide, please. So if we look at the data produced by accredited laboratories, really it's used as a safeguard to the health of the public and the environment. Really, it just highlights how important it is that we have a robust and high quality accredited laboratory community. The data is used to inform management decisions of the regulatory activities. And ultimately, the data, when we utilize that data and it's high quality data, the decisions that we make lead to better policies and regulations. So essentially, you help shape our regulatory framework and our activities. Next slide. The foundation of this really is the robust laboratory accreditation standards that the laboratory community follows, and implementing a quality management system. Because we have, or because the laboratories follow and implement a quality management system, we know that they have the policies and procedures to document and control and monitor data quality. This is really important for us from a regulatory agency perspective, because we know that if there is instances where the data, or if there are errors or deviations, or even uncertainty with the data, that the system will be able to recognize that, implement corrective actions, and adopt a continuous improvement model. That's why we have really faith and that the data provided by the laboratories helps to support us, and it's consistent, it's of high integrity, and it's of the quality that's needed to make the decisions at the water boards. By the way, let me just quickly take a sidestep and say congratulations to those T&I early adopters. We know that the T&I 2 is new to some of you, and it's the commitment that's shown by the laboratories and the early adopters is good to see. Next up. So at the water boards, I'm responsible for upholding or maintaining the data quality standards. The laboratory community also helps uphold those data quality standards at the water boards, because their adherence to our data quality standards ensures that there's accurate, consistent, and comparable data that we could use in our management decisions. And really that occurs because the laboratories are adopting customer service focused quality management systems that help them recognize when the data quality meets the needs of their clients or meets the needs of their regulatory purposes. And that's why I want to celebrate you as a laboratory community in helping us uphold our data quality standards. Next step. All right, so the laboratory community is also integral in advancing the analytical needs of our programs. So in today's society, today's efforts, we're looking at lowering detection capabilities of our analytical methods. We're looking at analyzing state-specific analytes. We have programs dedicated to constituents of emergent concern. We have been asking the laboratory community to analyze unique matrices, whether it's fish tissue or recycled water, or the discharges from desalination plants, so like brine discharges, and or providing data that is suitable for the program needs. So for instance, our beach monitoring program public notification timelines really dictate that the old traditional bacteria indicator methods are really not helpful in announcing or notifying the quality of those waters. And so helping us advance into new approaches to help monitor those beaches is where the laboratories are helping lead the charge. Next step. The laboratory community is also partnering with us to advance and adopt and implement new methodologies. So there's been times where we have to look beyond the approved methods that are used in our Keystone monitoring programs, those that are approved for use in our Safe Drinking Water Act or Clean Water Act compliance monitoring programs. There's times where we're asking the laboratory community to help us identify, validate, and implement methodologies that help advance our testing capabilities and address emergency challenges for the state. And we have numerous instances where the laboratories community has stepped up and helped partner with us in bringing those methodologies to light. Just to name a few examples, we have the PFAS investigative orders where really from a state perspective, we didn't have a clear infrastructure or lab capacity to do this monitoring, and bringing that online quickly with the DoD QSM method approach was just a huge example of how the laboratory community helped partner with us to elevate and move forward with those investigative orders. Another example was when in the pandemic was the implementation of SARS-CoV-2 monitoring, utilizing new and unique techniques for surveilling wastewater, and it was part of the uplifting of our wastewater-based epidemiology program, and help contribute to the National Wastewater Surveillance System, the NWSS. So that was all based on the laboratory community partnering with the water boards and our partner agencies, California Department of Public Health, and providing high quality data and being able to utilize that data to help surveil the wastewater. Another example, lastly, is the microplastics, where the laboratory community has come together to help scrutinize and actually help inform the ELAP and Division of Drinking Water on the quality control mechanisms that can be used in microplastic analyses. And right now that is now offered as an accreditation through ELAP. Next step, or next slide, please. The laboratory community is helping us in method validation needs that we have for our programs. So in coordination with laboratories, there are submittals of method validation packages to showcase that methods used in our programs will meet the performance needs and data needs of our programs. So in these efforts, the laboratory provides a method validation package. It's reviewed and then approved for use by the program, and then we partner with ELAP in requesting a accreditation to that method so that it can be used in for these regulatory purposes. So those method validation packages are detail the method performance data. It's matrix specific, so it's really targeting the needs of the program. And alongside that, that SOP is scrutinized to make sure that it includes the necessary quality control and quality assurance procedures to support high quality data. We have numerous success stories of these efforts, which include pyrethroids for low-level analysis needs from Region 5 Basin Plan Amendment, imidacloprid, also low-level analysis needs based on irrigated lands regulatory program, as well as organotins and nitrosamines for other programs at the water boards. Next step. Next slide. We also share partnerships with the laboratory community in adopting and implementing non-traditional analytical tools. These opportunities are used to expand beyond, again, our traditional analytical tools. We're used to very targeted analysis, but we can expand beyond that to maybe use more surveillance-like monitoring tools, like the estrogenic response or estrogenic receptor and alkyl hydrocarbon receptor response cell biopsies. These measure bioactivity of waters across the state. So we can look at it from a holistic level, whether or not the water is actually resulting in bioactivity, which then can be further investigated. Techniques like eDNA testing to look at various species that may be in water bodies that may turn into look at invasive species, or even the health and quality of those waters based on the presence of environmental DNA. And even more recently, and this is something that we could will probably be explored in future talks or tomorrow, I believe, absorbable organic fluorine or extractable organic fluorine analyses. Although these may be somewhat like traditional analytical tools, the way that they're applied is being used in a unique way to look at it from a screening perspective. And so these are just examples of how non-traditional analytical tools are being utilized, and partnerships with laboratories to scrutinize these tools to make sure that the method performance and data quality meets the needs of our programs. Next slide. Our programs are also exploring the use and utilization of non-target analysis, which within our programs, we're partnering with the environmental laboratories to think about how to implement these analyses in a regulatory framework. These are beyond our traditional like standard use of standard analysis, like calibration standards. What's a one-to-one relationship with a known contaminant, and we can measure it accurately. Those are kind of traditional targeted analysis for it, but we're looking to expand that to a non-target analysis, and we're partnering with those laboratories to develop standardized approaches, and when necessary, implement QC that can help evaluate performance and data quality. And then also working with the laboratories on how to utilize that data. How is it reported? How is it used? Because it's not a measurement of concentration, although you can, with these non-targeted analysis tools, report a kind of semi-quantitative result. It's how do we report those and utilize those in our regulatory frameworks. And we partner with the laboratories to make sure that we are adopting those and implementing those in a way that will support our mission. Next slide. So what's our future outlook? Well, as I just stated throughout, is that we really rely on the accredited laboratory community and plays an essential role in California. And partnerships and collaborations like the ones I highlighted above are becoming increasingly more important in order to address our emerging challenges. So we rely on the laboratory community to provide us sound data and to adhere to our quality, our data quality standards. So the laboratory community, especially the accredited laboratory community, is going to play a vital role in the responses that we face in California, specifically associated with our missions at the water boards. So we have safe, affordable, accessible drinking water. You know, how are we going to be able to utilize the tools that I mentioned above in those efforts to make sure that everyone in California has access to safe and affordable drinking water? We have a really diverse portfolio of water management tools and strategies that we can deploy at the water boards, and implementation of those tools are going to rely on the data that you help that will indicate the effectiveness of these water management strategies. This includes recycled water, direct potable reuse, and then also desalination. So we're expanding kind of our water management strategies and portfolio, and the data that you provide is going to be integral into those efforts, as well as efforts, the climate-related hazards like drought, wildfires, flooding, etc. Those all kind of play into the integrated waterman strategies that we adopt and responses to those, specifically in response to drinking water, in response to access to waters and management of our resources. So those all come into the laboratory community, all plays a central role in helping us fight these climate-related hazards or address them. Next slide. All right, so that's the end. Hopefully you understand that we at the water boards and other regulatory agencies really do rely on the data provided by the laboratory communities. And if you have any questions about what we're working on or advancements in kind of our monitoring efforts, please feel free to reach out to me at andrew.hamilton@waterboards.ca.gov. Thank you.
Perfect. Thank you so much, Andrew, for that perspective and that great point of view from the state. We are welcoming questions for Andrew, so please use that Q&A chat box right now if you have any questions. We would love to have Andrew answer them for you. And to get us started, we have one coming in right now. I can see someone's typing, so give it just a second. Okay, here we go. What is the single most important takeaway from you regarding quality in laboratories?
That's a good one. I would say that it's an ongoing effort, right? Quality is something that you have to work towards, and it's adopting that continuous improvement model is the one thing that I get from quality in the laboratory community, is that it's always evolving, right? But that we do rely on the quality of the data that the laboratories provide. So adhering to standardized policies and procedures is really, really important.
Great. And then I'll publish this for everyone to see, but someone else in character here says presentation is good. It is, Andrew. So thank you for joining us in our nerdiness. We appreciate that. So we have another question about your experiences implementing quality as a lab director. Can you just tell us any little tidbits about what you did?
Yeah, that's okay. There's so much to talk about, but as a lab director, you really, I think it's really important to understand and support your staff, right, in achieving data quality and implementing the proper policies and procedures to support your staff. I think in whatever you do, it's a customer service driven industry, right? So we understand that, at least from I was working at a commercial laboratory, so it's a customer service focused industry, right? And so you implement a quality management system that's really focused on making sure that the products that you provide to your clients meet their needs. But more importantly, I thought that in that endeavor, that supporting the staff and making sure that they have the available resources and knowledge and training to really realize that data quality that meets your needs of your clients is really the most important aspect of being a laboratory director.
Great. I'm still waiting for a couple more questions. I'll give people a minute to type them in. So the joys of being live, right? We have in real time here. All right. Let's see here. If we don't have any more questions, I'll give it just another couple seconds. If not, you guys might take a break a little early. Okay, so thank you, Andrew, so much for being here. We really do appreciate all that you have to share and for the good answers to those questions. We have just a short break right now. We have a little activity for everyone during the break if you want to join in. In the chat, you'll see a link to menti.com. If you follow the link and you type in our unique event code, you will be prompted to type in where you're watching from. So no matter where in the universe you are, right? So just type in where you're watching from, and then we'll be sharing a word cloud with everyone's locations. Also, don't feel like you have to. So feel free to get up from your computers, refresh your coffee, do whatever you need to do, and we will see you back here at 10:40. All right. Well, that is 10:40. I asked our fabulous producer, Leanne, to leave the Menti up for just a second so you guys can take a look at all over the great state, wherever you are. The way this works is the ones that are a little bit larger is more people have put those in. So as expected, some of our bigger cities are listed a little bit larger. I'm joining you personally from lovely Woodland, California. But I noticed on Slack someone was asking where ELAP is. So we have a fair amount of ELAPers joining us from the general Sacramento area, but we also have ELAP down in Southern California based out of our Glendale office, and we have some out in beautiful Richmond, California as well in that general vicinity. So ELAP is well represented all over the state. So thank you so much for coming back to your computers, and we are just going to go ahead and keep right on going. As a reminder, feel free to type in your questions throughout the presentations. We are happy to have those ready to pose to our presenters as soon as they're done with their presentations. At this time, we're going to head over to ELAP's very own dynamic duo of Chris's. First, we'll hear from Chris Hand and then Chris Ryan. Chris Hand works as ELAP's state agency liaison. Christopher is one of ELAP's laboratory certification officers responsible for accrediting drinking water laboratories and works in coordination with the quality assurance units at the Division of Drinking Water and the Office of Information Management and Analysis in the state water boards. Go ahead, Chris, it's all yours.
Thanks so much, Jen. Thanks everyone for being here. I was keeping my eye on where everyone's from to kind of tailor my presentation here, and I did see some folks from outside of California. So to those who are from elsewhere, welcome. This presentation will have like one slide that's applicable to you, so I'll point it out to those folks there. But in general, this presentation is mostly focused at how California has implemented the US EPA's methods update rule that was published in 2021, and kind of the general background of how it works here in California. So there might be some that's less applicable. Maybe if it's just that I think I just saw Seattle. I think I saw one other place. So those two people here, but I'll make sure to point that out for you as well. And with that, let's go ahead and move forward. I am going to put a disclaimer to say that while there are many requirements, I don't want them to get confused with my personal recommendations or things your laboratory can do. So don't take everything that I say here as the regulatory requirements that you need to comply with. I did make sure that everything I'm saying isn't incorrect, but please don't take anything that I say as a rule. Those are published on our webpage and published in the Code of Regulations. So next slide. And with that, we have a whole web page that's dedicated to the 2021 Methods Update Rule. It's got a bunch of situations of how your laboratory could fit in, different options. There's a whole table that's full of all of the changes that have changed between the pre-2021 Method Update Rule and post-2021 Method Update Rule, kind of what methods got added, what methods are changed, what are replaced. And a bunch of guidance and suggestions for laboratories. So if you haven't checked out the website, please do. It is got a lot of information on there. And every question that I've seen has had at least part of it addressed on the website. So please take a look at the website. There's been a lot of work put into that. So next slide. So with that, I'm going to go over a little bit of the background of how a method update rule works at US EPA, walking down up from the federal level all the way down to ELAP. So the US EPA for non-potable waters, typically under an NPDES permit or non-point source discharge elimination system, also known as a Clean Water Act. There's a variety of other acts that also fall into the Clean Water Act, but that's promulgated by the US EPA under 40 CFR 136. It's got a whole scheme of what methods are allowed to be used It also has some minor changes, such as holding times for specific analysis if you're using a different method. It's got some extra preservation requirements in there that EPA has done research on that say, hey, these, if you do it this specific way, the holding time is this long. And it's also got some allowable modifications that could be made to the method that you're using for Clean Water Act compliance. Not every state has a authority like California. There's some states that don't implement the Clean Water Act themselves at all. So there's not a water board, there's not an ELAP. So the EPA
It looks like Chris is having a little bit of a technical difficulty, so we're going to just give him a second to get that resolved. He had a little problem this morning, so I apologize for this.
Yeah. Hear me?
There you are.
Okay, great. Turn off my camera. I did have a spotty connection, as Jen said. I missed out on some of the wonderful opening conference. So, okay, I'm still getting notices that thing frozen. I hope I'm still here.
You're good, Chris.
I'm good. Okay, great. Hopefully you didn't cut me off at anywhere. Like I was saying, Drinking Water EPA has a 2-year implementation window that they built in, which allows for a little bit of a delayed response. So we can go on to the next slide and I'll kind of touch on what the state requirements are. So the state and the regional boards implement the Clean Water Act here in California. They also have the provision that all of the testing that's done needs to come from an ELAP accredited laboratory. And these entities issue permits that's reference 40 CFR 136. And so these are the agencies that are picking which methods they want to see and which methods they want to get for their data quality needs. They reference the CFR, so that doesn't mean necessarily that every method is going to be offered for accreditation, but if you're looking for an alternative method, they are restricted to using methods in the CFR unless they go through an ATP request, and that's done at the state water board level. To submit an ATP request to the US EPA for either a local situation, a statewide exception, that kind of thing. So if an analyte is on one of the tables in the CFR, EPA is mandating that one of these is going to be the option to use unless they kind of determine otherwise. And so that all is done at the state level, kind of in consultation with ELAP, more keeping us in the loop, but they're the ones that are receiving the data and evaluating the data for their regulatory purposes. So next slide. And then it comes to ELAP, and we get a request from the region board or the state board that says, hey, ELAP, we would like you to offer this specific FOA. And then ELAP offers that methods for accreditation. It does take a while for the state review process. We want to go through and make sure that all of those methods that are updated or changed aren't going to majorly impact our ELAP program or majorly impact the data that the board is receiving. So that process isn't immediate. We need to do that same kind of evaluation that you would do in your laboratory to make sure that the change is going to be as a minimal impact, right? And this implementation also had a lot of feedback from the laboratory community, where we sent out draft guidance to get some comments on it ahead of time, just to make sure that we were touching all of the bases and making sure we were mentioning all of the things that were important to our laboratory community when we rolled this out. So that did add a little bit to the delay as well. The next slide. For those who want to see the specific changes, we have a whole change log of all of the methods, what they were before and what they are now. somebody pointed out that this table is actually incorrect from our website, and we updated that table. Luckily, it was correct on the FOA tables. But here is just a snippet of some of the methods, and it's got on our specific MUR changelog table, it's got a specific table of whether or not a on-site assessment waiver is going to be available, or whether it's a new methodology where an on-site assessment would be required. So if we go to the next slide. So what is a waiver? What kind of things does that apply to? That applies to a method update, as we're going to call it, where they're changing the version of one method to a version of the same method, but a newer edition. So standard methods, 9223B, for those who don't know, for call alert, that's a frequently tested one, testing total coliforms, E. coli. This one changed from the 2004, which was a promulgated version, to the 2016 promulgated version. I can't recall exactly which specific editions there were, but standard edition or standard method print editions are slightly different than the number that's printed here. There's often a lot of overlap between print editions, where 2004 may be in 2 editions and 2016 is in one of the newer editions. If you have access to standard method online, you can check that out. There's also some guidance on our MUR webpage about how standard methods identifies things and how ELAP references those. If you're only updating to that newer version, right? So you already have 2004, and I get another, does anyone have audio? You guys hear me in the presentation? Yes. I see it good. Okay. If you already have 2004 and you're updating to 2016, we have an on-site assessment waiver available. There's a reduced fee available, provided that you do some specific things. The method or the waiver has a bit more description on how you would achieve that, and kind of what you need to file in to get that waiver. However, that waiver does not extend to the proficiency test system. So what we're doing, or proficiency test sample. So what we're doing there is we want to make sure that the laboratory has reviewed the method and made sure that the updates are implemented in their laboratory. And so that's why the waiver doesn't extend to the PTs. We go to the next slide. We'll talk about a new method. So some of these are some new techniques. Like one of these, a nitrite is based on an enzyme reduction. I don't think it's this one specifically, but it's a totally new technique. You can use part of the same instrument. However, some of the reagents are used are changed, and so in that case, we're not granting a waiver for these. They're a new method at the laboratory, so it's the standard requirements, an on-site assessment, a proficiency test, the standard kind of fee, that kind of thing. And all those are highlighted in green, and on the far right of the MUR changelog, it says OSA required. So that's kind of a guide for you there if you're looking to add one of those new methods. Going to the next slide. Going to touch on PTs just a little bit. Stay tuned for Chris Ryan's talk afterwards, but this is kind of an example of a PT report that somebody has done for their minerals and solids. We are asking you to write what method you use to obtain that PT result. That's the requirement, and that method that you write needs to match one of the methods in which you hold accreditation for. So for this example, for total suspended solids, the laboratory reported they were using standard methods 2540D version 2015. So if we go to the next slide, I'll kind of zoom in on what kind of PT information that we're looking for, and what PT information you should review at your laboratory is, did you pass, right? That's kind of the important one. If you don't pass, you're not going to get anything. Does the method description reflect the methods that you use to obtain accreditation? This is the part where we are going to be looking for that application. We want to make sure that the method that you use matches ELAP's listed fields of accreditation. So if you're using the new method, then we want to hear, or we want to see that the new method is listed in that PT report. And Chris Ryan will talk a little bit more about efficiency tests and kind of how to look at those ones closely. So for those laboratories out of state, I know we got a couple here. You got to get your primary accreditation updated. How your primary state implements those is up to them. So check with your primary AB to figure out what their requirement is. If you have that updated, you can make changes during your typically annual reciprocity application. But if you're off cycle, if you've already submitted a reciprocity application this year, you can update it with an amendment application, provided you have that updated primary certificate. So kind of talk to your primary AB on how to meet their requirements in terms of meeting them as well. So next slide, please. So a lot of frequent question is, when do I need to do this? Talk to your regulator or your clients. We're not the entity that writes the permits. We don't receive the regulatory data. We can't really advise you on when specifically, other than the sentiment that we get from the regional boards is they're allowing time for transition. So they're understanding that transition wouldn't be immediate because the laboratory needs to obtain accreditation for a new method. ELAP's going to keep the old FOA tables until February of 2024. This gives you quite a bit of time. So all those laboratories who have a certificate that's expiring soon don't need to rush and update theirs immediately if their regulator says they can have some time to change. But our recommendation is kind of do it as soon as you can, because you're going to need to file an amendment application, which means you need to make sure that your laboratory is implementing the procedure. You need to make sure you can pass a PT using that new procedure if it's updated, if it needs any changes to your laboratory's procedure, that kind of thing. So if we go to the next slide, I have a suggested order for those who are curious. To start with, I would look at the method update rule webpage, look at the FOA changelog, compare that to what your current scope is, see if you need to see how many methods you need to change or review in your laboratory. Some folks might be lucky and they might have nothing. There are common methods that are commonly used in a lot of laboratories that are changing. So you might have one or two that are going to be changed. And then look at that newer standard method or ASTM method that have those changes and make changes in your SOP as needed. So I would recommend if you document that review, count it as part of your internal audit. You're looking at your laboratory's procedure to update your change. And so document that'll count as part of your annual internal audit requirement. If you need to make any edits to the procedure and train staff, some folks have noted that the standard methods is actually a little bit looser, so they are like, we're not going to change anything and we're compliant with the new requirement. So that'd be great. If you need to train staff, just make sure that's documented. If we go to the next slide. Next, it would be get your PT samples. Those don't necessarily need to be separate PTs, right? If you're able to use your PTs in your normal time slot, that would be okay, provided that you meet all the regulatory requirements for having your PT either on your one annual year or your right before your renewal application. Make sure that PT method name matches ELAP's fields of accreditation, and have somebody else look at your results before submitting them to the PT provider. Helps just to have a second set of eyes, because you do get that fatigue looking at the same result over and over and over again. And then check out that on-site assessment waiver and fill it in. There's kind of a checklist at the very beginning to say I'm agreeing to all of these things. And if you have an on-site assessment that's needed, I would get that scheduled before you order the PTs, and then get those PTs done so that way you have a result for the auditor to look at while you're there in your laboratory. Then get all those documents for your application ready. We do know it's a lot of documentation, but keep all those together and submit them ideally before your next renewal application. I like to think that keeping them separate is going to make sure that they are all handled separately, and so that way there's no chance of you losing one FOA that you need because you try to combine a renewal and an amendment at the same time, but you didn't actually meet the amendment requirements, right? That would just be my concern as a laboratory. You can add them at the same time, but this is my suggestion. When you get that back, check it out. Make sure that all the things that you asked for are on your updated scope. And then your next on-site assessment, make sure your assessor looks at the methods that you have on your scope. Don't use your old scope because it's going to list the older methods. Might be a problem. So just kind of keep that in mind. There's a bunch of situations that we have on there, kind of when your certificate expires and recommendation on what you can do as a laboratory. But to update your active certificate, you're going to need an amendment application. That's the requirement. You can't make changes to an application during the renewal. The renewal is supposed to be renewing the same certificate for all of the things at the same time. So check out that website. It's got a couple of situations on there as well. Next slide. Doing a time check because I know we got a lot of questions and I want to get to some of them while I still have time. So what is my laboratory required to do? Since all MUR additions need to be done with an amendment application, your laboratory has a little bit of time to decide and implement. Your regulator might have a specific date that's needed. If you have a permit coming up and you need to update your certificate right away, that might be dictating your speed of which you're trying to update your certificate. When your certificate expires, if you expire after February 2024, you're going to want to get those on your certificate right away, so that way you can renew your accreditation come your next renewal application, and you can renew with those new methods, right? But when you're choosing to amend your accreditation is up to you. And then what you're required to do is dependent on your certificate and when you want to get that amendment application. So I've had a lot of folks asking, what am I required to do? And that's the kind of gist, but don't wait, because the option for renewing old methods ends in 2024. So if you don't have the new methods on your certificate, you can't renew your accreditation for something that ELAP doesn't offer anymore. If we don't offer it, then you're not going to be able to renew it, even if it's on your certificate. And lastly, I just want to leave you with 2 bits. Thank you so much to all of the laboratories who provided input on this rollout. We had a lot of bits of documentation that went to a lot of different people. You guys know who you are, and thank you so much. It really has helped give us answers to questions that I know a lot of folks have asked and are planning on asking. And if you like this process, if you don't like this process, please let us know. We want to make sure it's improved for the future. This isn't the only time a state agency is going to request ELAP to offer a new method and remove an old one. That's going to happen kind of frequently depending on what the use is for. So it's likely to occur in the future. Next slide, and make sure, if you haven't already, the folks here probably have at least one person that's been contacted and is subscribed to the email list, because that's how we announce all of our announcements, such as the MUR methods. So with that, I'm going to close and answer a whole bunch of the questions that folks have been asking here.
Thank you so much, Chris. I will do my best to kind of organize this this Q&A so it kind of makes sense.
Sure.
So kind of a succession of questions here. So maybe we'll ask them, and then there's some follow-ups. And Kate, thank you for your help in moderating the chat and doing your best to answer questions too. So one of the questions, do you have a recommendation for when to update SOPs to ensure staff understand method changes for demonstration of capability while we wait for the amendment application to be approved?
Got it. So for an amendment application, what you're doing is you're saying, hey, ELAP, my laboratory is capable of running this method. So that means you've already done a demonstration of capability in your laboratory. So for your update, it kind of depends on what it is in terms of how much broadcasting you need to do for that new change, right? Some of the changes are going to be pretty minor. That's why ELAP has an on-site assessment waiver for a lot of the methods, because the change pretty minor. Your laboratory probably already does that step. They're just a clarification on what is required, right? So that kind of thing is a little bit clearer. In terms of the change directly, yeah, you might have an entirely new SOP because it's a totally different procedure, right? That might be the step that you need to go to have two separate SOPs and say, I'm running this one for this method and this one for this method, and they're different versions there. But it's really dependent on what the change is, the situation your laboratory is in. And then in some instances, you might have two versions of an SOP that are active, but you need to demonstrate that those are active, but you're using one of them just to set up, run your DOC, run a PT, and the other one is your compliance testing until you get that amendment application where you get that new accreditation. Hope that answered the question.
Awesome, thank you. And then another one, if a lab wants to adopt a method modification promulgated in 40 CFR 136 for an accredited method, do they need to contact ELAP at all?
It depends, probably not. It depends on what that modification is. So these are very specific modifications, and in this Federal Register, it actually says you do need to contact your permitting authority to let them know what the modification is, and you need to have it documented in a very specific way. So that's a permitting authority kind of question. One of the examples is collision cell for 200.8, which is allowed under the Clean Water Act, but is not allowed in the Safe Drinking Water Act. Don't do that if you're drinking water laboratory. But it has very specific steps of you can do this if you document this and you tell your clients, right, who you're giving the data to.
And let's see here. Someone asked, where can we get where can labs get access to the new standard method and ASTM methods?
Right, both of those entities have online versions. Standard methods online changed the way it kind of works. So if you have access to standard methods via their online copy, they actually let you get access to all of their previous versions as well as their current version. So it could be that you can access a couple different versions of standard methods there with an online access. You can get a print copy of both of them, but both ASTM online and standard methods allow you to buy either single copies or buy a whole suite of access to get a whole bunch of different standards.
And kind of a follow-up or closely related question, which edition of standard method should be referenced for anything outside of the actual method, such as quality control or sample handling with the 2021 update?
That's a great question. And it is a little bit dependent on what tests you're doing. So the Federal Register actually does specify what version for some methods you need to reference. Our general recommendation is use the newest QA/QC section. Generally speaking, those are all free to access, kind of regardless from standard methods. The way that standard methods does it is it does make it a little bit confusing. But if you have a print edition, obviously you can just reference the print copy because you have a hard copy of your thing. But if you don't have a print copy, I would recommend your laboratory control a copy of your standard methods quality control sections and reference that controlled copy. We're referencing this one. It was published on this date. Here's the reference. It's in our lab. Right.
All right, it says the amendment application has section J, which deals with an on-site assessment. If we'll be using the on-site assessment waiver, should we just leave that section blank?
Yes.
That's the easy one. All right. If my ELAP permit has an expiration date after February 2024, will I be able to file the amendment after February 2024?
Yes. So provided you have the methods on your certificate, right? So the waiver requires you to have the prior version of the method and then the new version that you're moving to in order to get that waiver. And so if you have that old version on your method, it doesn't really matter when you submit that amendment application because you'll be able to do that kind of regardless. If your certificate expires after 2024, you're not going to be able to submit that renewal to renew old methods, if that makes sense. So if you don't have the old methods on your certificate, you're not going to be able to amend them with a waiver because you're not going to have the old ones on your certificate anymore. Hope that makes sense.
Perfect. And then here's a follow-up question about the methods modification question. How will we know if we need to let ELAP know about a modification in 40 CFR 136 the lab wants to make for a method they are credited for that has been determined as fine by the permitters/clients?
It really depends. You can always ask ELAP. I'm going to defer that to you. Send an email to the email inbox. We got staff on that. Well, I would say 24/7, but at normal business hours, that gets diverted to somebody who can help specifically with your specific question. So if you have a specific question on, hey, I want to make this change, is this going to be okay? Do I need to make any sort of change? Generally speaking, the method modifications don't allow for a change to any of the quality control, holding time, sample reservation. None of those things can change. So that kind of area is not something that you're going to make a change to anyway. So generally speaking, the change is like, oh, instead of doing this huge volume, I'm going to do a smaller volume, and the 40 CFR says that's permitted, right? That kind of thing.
Do I need to update method 9223B 2004 to 9223B 2016 if my renewal is in June of 2024?
Need probably. If you're going to need to continue to do that analysis. So if that's part of your permit, and your permit says, hey, you have to do this method, or you have to test for this thing, and you still need that update, then yes, you're going to need to submit an amendment application and update your certificate.
When can ELAP update FOAs for drinking water for standard method reference methods if these methods overlap with wastewater methods?
Good question. Drinking water isn't covered under the method update rule. So that is specific to the Division of Drinking Water and the Safe Drinking Water Act, and there's a whole bunch of different things that overlap there. I am in discussions with the Division of Drinking Water to update their sections because that is a common question we get from laboratories is, hey, how come drinking water is referencing this older version when wastewater uses a newer one? And part of that is they're different programs, so they have different needs. So that's kind of dependent on the interaction there. Stay tuned. They do want to announce those publicly when they're ready to move forward with an update. So.
And then someone's clarifying, are you saying we can use a QC section newer than the permitted method?
I would generally avoid that. It's more of use the newest approved version, right? So I think the promulgation, most of the methods they reference are in the 23rd edition. So if you have a 23rd edition, I would reference that. I would kind of keep it with the publication. Generally speaking, the QA/QC sections are not the requirement. The requirement references, the method, you need to do this and these specific things. So.
Perfect. Well, I think that conveniently we are out of time and out of questions. But Chris is hanging out on Slack. So if you think of any other questions later, he's happy to answer those there. And then if you think of questions after the conference, you're always welcome to send us an email at our ELAP inbox. Thank you so much, Chris, for all that information. And thank you all for such great questions. Next, I'd like to introduce our speaker, Christopher Ryan. Dr. Ryan joined California ELAP in 2016. In his current position, he's the supervisor for the monitoring unit, where he oversees review of proficiency test studies to ensure laboratory compliance with program procedures and regulations. Today, he's going to share some insight into all things proficiency testing. Please welcome Chris.
Thank you, Jen. Good morning, everyone. Happy to be here today. As Jen mentioned, I'll be talking about meeting the proficiency testing requirements for California ELAP. Next slide. So I wanted to begin my presentation today by talking about the importance of reading the California ELAP regulations, and in particular, the proficiency testing section of the regulations. I have shown here a screenshot of the main ELAP webpage. If you scroll down to about the middle or so of this webpage, you'll find a link to laws and regulations. Clicking on this link will take you to the laws and regulations webpage, where you can access the California Code of Regulations. The California Code of Regulations includes the full text of the California ELAP regulations. Can you go back one slide, please? Thank you. So once you're at the California Code of Regulations, you can navigate to the accreditation requirements, which is in Article 2. I would recommend, if you have not already done so, reading all of the California ELAP regulations, paying close attention to section 64802.15, which is the proficiency testing section of the regulations. Next slide. So it's really important, and I can't emphasize this enough, to read and understand this section of the regulations. Doing so will really help your laboratory to meet the PT requirements for California ELAP. I have a screenshot shown here of the proficiency testing section of the regulations. Please check it out when you have the time. Next slide. So in addition to reading and understanding the ELAP regulations, it's also really important to understand the accreditation cycle. Understanding and reading the regulations and understanding the accreditation cycle will go a long way to helping your lab meet the proficiency testing requirements for the program. So I wanted to spend a few slides just talking through the accreditation cycle. All laboratories operate on a 2-year cycle. Every 2 years, your laboratory renews accreditation with California ELAP. The 2-year cycle is broken apart into a first year called an annual year and a second year called a renewal year. There are some important dates associated with this 2-year cycle. The first is the certificate effective date. That's the start date of your certificate. Also, a certificate expiration date. That is when your certificate expires. That covers the 2-year cycle. Now, within that 2-year cycle, there are two important PT deadlines. The first is what we call the annual PT deadline. That occurs after the first year of your 2-year certificate. And the second is the renewal PT deadline, which occurs during the second year, and not quite at the end of the second year, but close. And we'll talk more about these dates in detail in the next slide. Next slide, please. Okay, so let's talk about which PTs to do and when to do them. Again, we're looking at a 2-year cycle for all laboratories, broken up into a first year and a second year. So when your lab is doing PTs during the first year of your 2-year cycle, your lab's PTs must match what's on your laboratory certificate. Very important. This will ensure that your laboratory meets the annual PT requirements. In the second year, when your lab is doing PTs, your lab's PTs must match what's on the ELAP field of accreditation tables. Also very important to understand this. Doing so will ensure that your lab meets the renewal PT requirements. I have a side note here for the second year PTs. When you're doing those second year PTs, those will usually match what's on your lab's current certificate, but not always. The best thing to do before doing those second year PTs is go to the ELAP website, check out the ELAP Field of Accreditation tables, make sure that what ELAP offers matches what's on your certificate, then you're good to go to run those second year PTs. The FOA tables are updated, and you don't want to be doing PTs for FOAs that may not exist or may have changed. Next slide. Okay, so let's talk a little bit more about knowing when PTs are due. I have an example here of a fictional lab that we'll call California's #1 lab. And I want to walk you through the dates for this fictional lab because the dates can get a little complicated, but it's important to understand them. So let's go through an example for this laboratory. So California's #1 lab operates on a 2-year cycle, just like all laboratories, broken up into a first year and a second year. This lab has a certificate effective date, a certificate start date of June 1st, 2022. So for this lab, their certificate will expire 2 years later. That would be on May 31st, 2024. There are 2 important PT deadlines that I mentioned in a previous slide. For this laboratory, their annual PTs are due on or before May 31st, 2023. So during the first year, this laboratory had a full 12 months to complete their annual PTs, June 1st, 2022 to May 31st, 2023. In the second year, the laboratory also has a set of PTs, a full set of PTs that are due. The renewal PTs are due for this lab on March 2nd, 2024. In the second year, laboratories don't get a full 12 months to complete their PTs, unlike the first year. The reason for that is the PTs for the renewal application are due when the laboratory submits the renewal application, and that occurs at least 90 days prior to the current certificate expiration date. So for this lab, May 31st, 2024 is the expiration date. So 90 days prior to May 31st would be March 2nd. So in the second year, this laboratory, and actually all laboratories, have about 9 months to do the second year PTs. Keep in mind that when we review your laboratory's PTs, what we are looking for is the close date in your PT studies. I'm sure all of you are aware that with these PT reports, there are a number of dates associated with them. There's an open date, there's a close date, there's an analysis date, there's a report issue date, and then there's the close date is the date that we look for to ensure compliance with these 2 important deadlines. Next slide. The dates for these PT deadlines can be confusing. It can get complicated when trying to sort out when your PTs are due. To help with this, ELAP has developed a timeline guidance tool. Hopefully all of you are aware of this. If you're not, you can go to our main ELAP webpage and scroll down to about the middle or so of the web page. On the right side, you'll see a section called Timeline Guidance Tool. You can use this tool. There's no charge, no cost. It's free to anyone who wants to use it. You will need Microsoft Access in order to use the tool. It's based on Microsoft Excel. So clicking on the Timeline Guidance tool will automatically open up, if you have Microsoft Excel, an Excel document that looks somewhat like what you see on your screen here. Many of the cells will be blank. All you need to do to utilize the tool is enter the certificate expiration date in the box shown in row 3. Once you type that in, the tool will populate with lots of really useful information for your laboratory. There is important dates for your laboratory's on-site assessment timeframe, for example. There is information on your application due date that gets populated in this tool, as well as information about your proficiency testing timeframe. So let's take a look at this example when we put in May 31st, 2024 as our certificate expiration date. You'll see here under year 1 PT acceptance range, hopefully you can all see this, the date that your PTs must close for this laboratory would be June 1st, 2022 through May 31st, 2023. This information gets populated in the tool for you once you put in the certificate expiration date. The second year PT acceptance range is also shown in the tool. For this laboratory with an expiration date of May 31st, 2024, the second year PTs have to have a close date of between June 1st, 2023 through March 2nd, 2024. A really useful tool, would encourage everyone to check it out. Also under the PT section, there is a recommendation from ELAP for when your PT should be completed. In this case, the recommendation that pops up is for this laboratory to complete their PT sometime between September and November of each year, September, October, November. If this laboratory did their full set of PTs during that time frame for each of the 2 years, you would be in good shape for meeting the PT requirements for ELAP. Next slide. So I wanted to cover some of the basics of our PT requirements. If your laboratory can meet these basics, that will go a long way to ensuring that your lab is compliant with the PT requirements. So first, each field of accreditation requires a PT. This is almost always the case. There are some exceptions, but generally each FOA requires a PT. If you do come across a case where your PT provider does not offer a PT, it's important to check with our other proficiency testing providers to make sure you get all of the PTs that you need. Not all of the PT providers will offer a PT, will offer PTs that your lab will need. Sometimes it is the case, but not always. Keep in mind that your PT results must contain the correct analyte and method listed. The PT results must be in the correct matrix. Your PT results must be completed within the acceptable time frame. We talk quite a bit about time frames. And of course, your PT must have an acceptable evaluation. It's not enough just to do a PT, you have to do a PT and pass a PT. And finally, all PT results must be completed and submitted with your application. Doesn't matter whether that application is a new application, an amendment application, or a renewal application, all PTs have to be completed and submitted with your application. Okay, so I wanted to list some common PT problems for laboratories. this is not a comprehensive set, but it's some of the common problems that we see laboratories having. First, forgetting to complete all PTs. This can be difficult, I know, for some laboratories when PTs are done sporadically throughout a year, especially if you're a large lab. This can be challenging. That this is a common problem. Forgetting to complete all the required PTs. Also, when it comes to reporting, the method reported in a PT study not matching the method that's on a lab certificate or on the ELAP field of accreditation table is another common problem that we see for laboratories. Also, PT sample matrix is not correct. You cannot use a drinking water or a water supply PT for a wastewater field of accreditation and vice versa. The matrix of your PT needs to match the matrix of the field of accreditation. Also, a common problem is the PT study is not within the acceptable time frame. Sometimes laboratories will submit PTs that are just too old and outside the acceptable time frame. And finally, a common problem is not checking with all of the ELAP approved PT providers for a PT that a laboratory might need. Next slide. So I wanted to zoom in on a couple of our most common PT problems that we see from laboratories and just kind of highlight these, talk about these a little bit. The first is missing PTs. It's really important that laboratories check each FOA and make sure there is a corresponding PT. This applies for your annual PT requirement and for your renewals. You want to make sure that for each FOA there's a corresponding PT. You really do not want to forget to do all your PTs. That can be a big problem. Second really common problem that we see is when your methods that are reported in your PT reports don't match what's on your laboratory certificate or on the ELAP field of accreditation table. Reporting can be a challenge as well as getting all your PTs done. It really requires a lot of organization, a lot of planning, a lot of second review, and a lot of attention to detail. Next slide. When it comes to reporting your laboratory's PT results, I know this can be challenging. Not all of the methods are listed by the PT providers. PT providers, I think, provide a great service to the laboratories by offering drop-down menus that list many of the commonly used methods that labs use for analyzing a particular analyte. It's sort of a double-edged sword. It really helps in shortening and making it easier to report lots of PT results when you can just click on a drop-down, select the method that you need, and then you can move on without having to type in so much information. Unfortunately, the PT providers don't list every single method possible that laboratories could use for analyzing a particular analyte, and that's where it can be a problem. So what you don't want to do when reporting your results, especially your method description, is select a method that seems close to your method, like the revision year is close to the one that you use. It's really important that the method reported in your PT result match the method on your certificate or in the ELAP field of accreditation table. Keep in mind that when you are reporting your results, you can manually type in the method that you are using into the report. The PT providers allow this, California ELAP allows this, and if you have difficulty when reporting your data or your methods, the best thing to do is contact your PT provider. My experience has been they all provide excellent customer support, and they can help you ensure you get exactly the method and results that you need to into your PT result. Next slide. I wanted to include one slide on what to do if your laboratory has failed PTs. With the new ELAP regulations, laboratories are required to take additional action when you fail PTs. I think, having worked in a lab, I'm comfortable saying that if you work in a laboratory long enough, you will likely have a failed PT. ELAP recognizes this, so it's not the end of the world, but there are certain steps that you need to take if your laboratory fails a PT. There are two specific scenarios that the regulations call out. First, when you fail a PT on the first try, and what you need to do if your laboratory fails a second subsequent PT. I just wanted to take a minute to go through these. So for a first failed PT, the laboratory within 45 days shall do a number of things. First, notify ELAP of the non-acceptable score. Second, document the root cause of the failure and take corrective action. Then obtain an acceptable PT and notify ELAP of the acceptable score. If your laboratory follows up a first failed PT with a second failed PT, then things, I would say, get a little more serious. For a second failed PT, the laboratory shall notify ELAP within 3 days of notification of the second failed PT. Be suspended immediately for that field of accreditation, cease reporting of results for regulatory purposes, notify all affected clients, and within 30 days document the root cause and take corrective action. I have at the bottom of the slide here the where to email notifications. It's to our email inbox for PTs. It's a dedicated inbox just for PT questions. PT providers also use that to send us their reports. It's elapca_pt@waterboards.ca.gov. Next slide. I also wanted to include a slide on the PT Q&A just to talk a little bit about some of the common questions that we get from laboratories. First question, can I turn in my laboratory's PTs after I have submitted my lab's application? So the answer to that question is no. All PTs must be completed and submitted at the time of application. That applies to an application that's a new application, an initial application, or an amendment application, or a renewal application. You have to have your PTs completed and submitted at the time of application. Second question, can I get an extension to complete my lab's PTs? No. Extensions to complete and submit PTs are not provided. It's related to the first Q&A. You have to have all your PTs completed and submitted with that application. Next question, if I misreport the method in my PT report, will my lab be required to purchase another PT? Yes. ELAP does not accept revised PT reports, and another PT will have to be purchased. I want to qualify this one just to let everyone know that when you are enrolled in a regular PT study, one that's a 45-day study, for example, after you've submitted results, you are able to update or modify any of your results within the open date and close date of the study. That is allowed by the PT providers, and it's allowed by California ELAP. You can go in and update data. You can update method descriptions. it's got to fall, those changes have to fall within that time frame of the open date and the close date. Once that close date of the study has occurred, then you won't have the chance to revise that PT report. Next question, should my lab always have PT reports sent to California ELAP? Yes. Laboratories should always have their PT reports sent to our PT inbox, elapca_PT at waterboards.ca.gov. And finally, if I have PT questions, who at ELAP can help? We are definitely here to help. If you have PT questions, please feel free to send those to us at our PT inbox, and we will get back to you very quickly. Next slide. So I hope with my presentation today, I've been able to communicate that PTs are a very important part of accreditation. I know that sometimes PTs may seem unimportant. They may seem like they're not worth spending time on. Sometimes they seem like they're too easy. This is a mistake. Don't underestimate the importance of PTs in your applications with ELAP. Failure to meet the PT requirements can result in a delay, loss, or denial of accreditation, as well as additional time, work, and cost for laboratories. Next slide. And with that, I want to thank you all for your attention, and I'm happy to answer any questions.
Great. Thank you so much, Chris. And as expected, we have lots of questions, so we'll just get right to it. Is it okay to use the same non-potable PT for the same method in both wastewater and ambient water if that is the only non-drinking water matrix from the PT provider?
So I believe on our field of accreditation table, the ambient water FOA table specifies at the bottom that a wastewater or non-potable water PT is required. That same PT can be used for a non-potable water FOA. So yes.
PT provider does not have low 123 TCP PT, but provide rapid response proficiency testing study. Is that okay?
Rapid response PTs are okay. For 123 TCP, the requirement is for a low level PT. If your laboratory's typical PT provider does not offer that low level PT for that analyte, I would recommend checking with some of our other approved PT providers for a low level 123 TCP PT.
Does the lab have to send PT reports to ELAP even if the PT provider sends official PT results just directly to ELAP?
That's a good question. Yes, so laboratories should have all of their PT results sent through their PT provider to us. In addition, the requirement for renewal applications, for example, is for laboratories to submit those PT results with the application. It does seem like duplication of work. We understand that. Our experience has been that it really benefits laboratories when they're assembling their application packages to assemble the PT reports at the same time and go through checking each field of accreditation in that application for a corresponding PT. It's really easy, I think, for laboratories to make mistakes when they don't have to go through that process. So yes, have all your PT sent to California ELAP, and also in your applications, follow the instructions and submit your PTs with the application as well.
Okay, and this is kind of a similar question. If all PTs are sent to California ELAP at the time of completion, do copies of the PTs need to be sent with the lab's application as well?
Yes, we get this question fairly often, and the answer is yes. We covered that, I think, in the previous question.
If a lab is certified for the same test method in FOA tables 108 and 126, is ELAP still allowing labs to submit results for a single PT sample for both?
Yes, I believe that is the case. 126 and 108 should both be non-potable water, or should both have non-potable water PT requirements. So wastewater PT would be acceptable.
Okay, this one's kind of unique. The certificate FOA shows method name SM23320, or I think it's supposed to be 2320B 1997, but the PT method is SM2320B 1997. Is this okay? The second repeat year indicates the standard method's addition update year.
Yes. So if there is a repeat of the method revision year, that won't be a problem when submitting your PT results.
If a failed PT was not sent to ELAP within the 45 days, what will happen when the renewal application is sent? The second PT passed, but it was outside the 45-day limit.
So ELAP has adopted a light touch when it comes to the 45-day window. Please keep in mind that if you do not meet that 45-day requirement, you're out of compliance with the regulations. And so my best advice is to, within that 45 days, make sure you get all of the steps that are required in regulations for a failed PT, and that way your laboratory will be compliant.
Okay, and reminding people we still have plenty of time for questions, so feel free to type them in. I have one more for Chris right now, but we're still welcome to more. Based on the timeline guidance tool, ELAP recommends PTs be completed at least 6 months prior to the certificate expiration date. What if ELAP changes the method name after the PT study for the second year accreditation cycle is completed, so the method name between the PT report and FOA table is no longer matched? It may still match the ELAP cert. Are we required to conduct another PT study even though we follow the guidance to meet the PT timeframe?
Yeah, that's a good question. So the answer is, if your laboratory was doing your due diligence and checking the ELAP field of accreditation table, and that table had a particular method listed on it, and you ordered your PT and reported your results in that way, then no. If the table changed after that, your laboratory would not be required to run another PT. ELAP knows when the tables are updated. We can see from your PT dates, PT report dates, and so that it wouldn't be necessary to run another PT if the table were to update.
Okay, and then we got a couple of these questions, and thank you, Chris Hand, for answering them, but I'll just say it out loud. Just a couple questions about when does the time frame start counting for that 45-day notification? That begins when you receive the non-acceptable score, not on the close date of the PT study. And then another question for you, Chris Rain. Can you confirm the leaching methods are no longer required if the analysis technique is covered under the accreditation? Yeah, that's correct. You can find that on the field of accreditation table for the leaching and extraction tests. I believe it says that at the bottom of that Excel table. Can we use method description for EPA 300.0 as EPA 300.0 2.1 1993, or do we have to type the revision?
Either one is okay. My best advice is to always report exactly as the method appears on either your certificate or on the field of accreditation table. Doing so, it will always be correct. In the case, if you report, your laboratory reports otherwise, then we have to take a look at what exactly you reported, and what exactly the method is, and so it can get complicated. For the example that you just gave, that would be acceptable, reporting it either way, but that's not always the case. So best to report that method as it appears either on your certificate or on the ELAP Field of Accreditation table.
Can I perform a PT study for the MUR amendment app and also include methods for my normal renewal? Meaning, can I use the PT study twice, so to speak, for amendment and renewal?
Yes, I think as long as your quality manual is updated, your SOPs are updated, that yes, you can do that.
Okay, and if I failed a PT and then completed the retest, is there a form for the corrective action, or do we just send the successfully completed PT report?
The requirement is for laboratories, if you read through the regulations, is to notify ELAP. The root cause corrective action documentation is just to be kept by the laboratory, in the laboratory, and to be made available to ELAP if it's requested. The results for the follow-up PT should be sent to California ELAP, and that's all that's required.
Okay, I think that's kind of the next question is similar. Says if you fail a repeat PT for the amendment, so if you fail a repeat, so you failed twice, then is an on-site required, or can we get an allowance for an acceptable score once the corrective action is complete and root cause addressed?
Yeah, that's a tricky one. I would say if you have a follow-up second failed PT that you're not sure about whether an on-site assessment is needed, reach out to the ELAP PT inbox. I would say generally that an on-site assessment is going to be required. If your laboratory fails 2 PTs in a row, that suggests something substantial or significant is wrong somewhere in the laboratory, either with the analyst, with the method, with the equipment. And for ELAP to be confident that your laboratory is competent to do that analysis, we would very likely require an on-site assessment to verify that.
And then if the method has a wider passing criteria, but the PT provider requires a narrower passing criteria, which is causing our PTs to fail, what should we do?
Contact me about that one. I would like to look into that if that's the case. Generally, that's not the case, but I can help with that. You can email me directly, christopher.ryan@waterboards.ca.gov, or you can send an email to our PT inbox, and I'll keep an eye out for that one.
Okay, it looks like we are wrapping up. I'll give everyone another minute or so to finish typing in any other questions they may have, but I think that with that, I'm going to officially say that's all the questions that we have for you, Chris Ryan. Thank you so much for being here, and thank you for your presentation. I know it's very helpful. Lots of great information. At this time, I'm going to ask my incredible counterpart, Kat Bloom, to give us a preview of tomorrow's agenda.
Thank you so much, Jen, and thank you to everyone who's still with us. This has been an incredible first day filled with unforgettable presentations. Please join us tomorrow for day 2 of ELAPCon, which we like to call the Moonshot. We will hear from some of our LTAC stars, starting with a presentation from Judy Morgan about LTAC's mission and goals for 2023, followed by a presentation on PFAS analysis from Augustin Pieri. Next, we'll talk about aquatic toxicity with Peter Arth, and finish up the day with an exciting presentation from Samuel Choi on OC San's ocean monitoring programs.
Thank you so much. And with that, we'd like to thank you for spending your morning with us, and we look forward to seeing you back here tomorrow at 9 a.m. I hope you have a wonderful afternoon.